Millions of votes a week. We have only one tagging system. Guanglei, how do you build the tagging for Arena?
Great question. We have not only millions of votes per week, but also for each arena, we actually have multiple categories and it's increasing. To handle it, it's a big challenge. And today we're gonna talk through this in our data pipeline design and how actually we operationalize it.
Mm-hmm. And before we start, can you give a high-level understanding about like how we collect data?
Totally, yeah. When the user come to us, give us a message in our ArenaAI, we actually give them two responses from model A and model B. From there, they can actually cast a vote whether they like A or B or both or none. With that, we're able to create a leaderboard with a rank, but also importantly for today, it's categories. So that the model labs have the details to look into their model's performance.
Yeah, like you say, we have like 29 categories for text arena only. We have even more for, I think, 7 for image and 7 for web dev nowadays.
Yeah.
So how do you build a system behind just like after we collect the data?
Yeah, totally. So we have a very scalable system and flexible enough to handle increasing number of categories. And we can actually wipe all this through. First is all the data from users, messages, and evaluations. We actually put all this into the Databricks so that we have a data lake to store the data. And then we have two levels of the scalability handling. The first layer is that all this data can be handled by a batch Spark job that incrementally to handle every hour data. So as long as we have incoming data, we will handle it hour by hour. On top of that, we have a generic tagging framework built in so that you can plug in a new tagger, and then for each tagging that we will call the API for LLM to be able to handle the categorization for each evaluation in concurrent way. Mm-hmm. So whenever we have hour of batch, we will do a batch job. Mm-hmm. The batch job will filter, of course, mm-hmm. and then put into, we call it a tagger framework. And there are multiple taggers for each type and each arena. Let's say we have a tagger here, and this tagger will compact and get all the context messages for each evaluation, and then set a request to our API for the LLM. This will take the prompt of instructions, how to categorize this message, and then return to the tagger to say, here's a list of the categories you can actually use. And then we output this category back into the table to say this evaluation belongs to a certain category. Let's say this can be a creative, writing, and also can be multiple for each, mm-hmm. can be medicine as well.
Yeah.
So with this, we created the categorization of the evaluation. And of course, this is concurrent.
Mm-hmm. I see. So from my experience, we have the batch job, and then this concurrency help us to parallelize the whole system. But I also had an experience of like when I interact with LLM, sometimes we'll get errors, and then sometimes the system will fully down. How do you handle this type of things on our system?
That's great. Yeah. So API of the LLM, the providers can be flaky, and also it's in many cases non-deterministic. So to handle those errors, operationalize it's a big challenge. To handle it in scale, it's even a bigger challenge. So for us, we have two layers. The first is that for each of those errors, we handle it in a way that log the information clearly into our data store, so that whenever we have some high level of errors that we need to look into in details, we can find those. So that just be able to find if it's our system has issues, if it's an API call itself has issues, or the LLM model itself has some issues. Second is on top, we have aggregate layer of monitoring and dashboard to alert if there's anything. And then those failure rate will be handled in real time by the concurrency control, so that if it has enough capacity, low enough error rate, we increase so that we can actually handle more with a high throughput, as long as the API can handle. And if the error rate is high, we actually back off a little bit to give some headroom for the API to handle. But in the end, if actually the error rate is too high, reach a certain threshold, we fail the job and retry later.
I see. This is how we actually have a sophisticated dynamic control, depends on the case.
Exactly.
And one question I also have is, like we say in the beginning, like we have several arena, and then we will keep introducing new tagging system, new tags we want based on the feedbacks from users, model labs. And how does the current system insert a new tagging we want?
That's a great question. So in our system design, we consider that in the way that the framework itself handle the tagger like with a unified interface. So when we need to create a new tagger, for example, webdev categories, so we call it a webdev cat here, that it's a new inherited class that we implement so that it will handle all the evaluation from this Arena webdev that we call the API for those evaluation with the context, and then we get back the output and then put into the data store for that kind of evaluation every one of them. And once we plug in, there's another way, another part is that we need to be able to backfill all the previous happened evaluation. That's not done automatically, so we need to actually use this same framework, create a new batch job to run the backfill through all these historical evaluations. And then combined, we'll be able to have the full image of new categories for each of those new or old evaluations.
So it's actually a two-stream. One is like a live vote that will come through, but there's also backfill jobs back from the historical jobs. How do you balance this on the concurrency design?
Yeah, go back to the concurrency control here. It's actually a pretty genius design that we are able to do it in a way that we can run them in parallel, and also we have the signal from the API to say if the error rate is high because of the too much concurrency for the API layer, then we will be able to back off, inch off, like if we monitor them closely, or just let them fail and then we can retry later. Because if the throughput here is high enough, the API cannot handle, we will have enough error rate that we will back off a little bit and to a point where the backfill job just fail and then we restart.
I see. So this is how we parallelize two different needs and then to handle the whole systems.
Exactly.
And I think like the whole system actually use a lot of like LLM API, but this will be a huge trouble for us if we didn't have a good cost control system. And how do you actually do this cost control?
That's a very good question, because we use a lot of tokens with all these calls, so it does cost us quite a bit. So we have a few ways to make sure that we are cost effective. The first is that we do the filtering, and also we have the idempotency built in, so that if a certain evaluation already being like categorized, we have the data to actually figure like we will skip those. So we don't do the recategorization to reduce cost. Another part is that we make sure that we have a good cost-effective that we evaluate based on the cost, that what are the API we should use that good enough for our categorization needs. So we have very good cost control over here. And on top, we have a dashboard to monitor the overall cost of those tagging system.
I see. So let me summarize a little bit to make sure we're on the same page. On the cost control part, first we do the filtering to make sure like we only tag the things that we need. So we put this huge, like sophisticated filtering system in the front to make sure we don't do the expensive tagging first.
Yeah.
And second thing is we have good quality and cost balancing between the selection of API we want to select.
Yeah.
And this is how we manage this. And on the whole system, we create a good dashboard to help us like managing the daily cost and then see whether there's just like a spiky stuff happens. And this is how we actually manage the cost on the tagging part. Is this correct?
Yeah, there's one more thing is that we do actually look at the size of the message for each evaluation. If it reaches a certain threshold, we actually cap it so that we don't send everything, have high cost. Instead, we send only what we need.
I see.
So those are the actual details we put in the cost control.
I see. So, but something I'm curious is like sometimes the message could be very, very long. And for those long contexts, it will be more expensive. How do you actually handle this in this system?
Yeah, we chunk it in a way that we only take a certain part of the message to send it to the API, not the whole message.
Oh, I see.
It's still effective enough for us.
I see. So basically we also have the mechanisms of context management on this tagging part.
Exactly.
That's very clever. So I think today we cover like how users actually vote for us and to collect how we collect the data. We also have the system designs of like is easily to plug in new tagging systems and then how we manage the cost. And also we have a clever concurrency design to handle the errors from the LLM. This is a very just like complex system, and I know like in the backend there's a lot of like the things doing and to make the ArenaAI have a good and maintenance leaderboard.
Yeah, it's a very very important to make it right as well, for the model labs to have all these categories needed.
Yeah.